solid, another is liquid there. That's not the solution. That's a heterogeneous mixture is not the solution. Homogeneous mixture is the solution. Yeah. Good. We cannot see salt and water separately or sugar and salt separately. All right. Now another one, sand in water and oil in water. So if you mix up, when you go to home and mix the oil and water together. So put some water here and put some oil here, and the oil will sit like this. So here you will see oil layer, and here you will see the water layer, right? So this is not the same phase. This is the oil phase. This is the water phase. So in some time we call the water is the aqueous phase and oil is organic phase. Yeah, organic phase and aqueous phase. We see two phases clear. They're liquid. The oil is liquid. Water is also liquid. I'm mixing them together, but they are not. I'm still seeing the oil phase and water phase separately. So that's not a homogeneous mixture. I see two separate. Make sense? All right. So, all right. Now let's go here and look the pure substances. So pure substance means it's uncontaminated. There is nothing, only one thing, pure substance. So let's say I have water. I have water here. I have water here. This is water. How do I know this water is pure or not pure? I don't know, right? So how do I know this water, I have water here. Now, whether it is pure or not pure, I need to test. So what I do is I boil this water. I put a thermometer here and I put it in a heater, right? Oven. And then the temperature increase and reach to 100 degrees centigrade. And the temperature never go above 100 degrees centigrade. It stays the 100 degrees centigrade always, meaning that it is boiling and boiling and boiling and boiling. The temperature doesn't go above 100 degrees centigrade. Make sense? That means this is water and there is nothing else. So it has a unique property. Make sense? Good. So if you boil water and it boils about 120 degrees centigrade, that's not water. There must be, somebody might have put some salt, or maybe somebody put something else there. It's not boiling at 100 degrees centigrade, meaning that that's not water. Yeah, that is water, but somebody mixed something. Yeah. So pure material has very unique quality, and if that quality is a little bit deviated either left or toward the right, then that's not a pure water. Not the pure thing. Yeah. Now let's look some. Let's take some ice here. So I put ice here in the beaker. I take out the ice from the fridge and I put it here, and I put the thermometer here. Now the ice starts to melt due to the warm in the room. So all the time this thermometer shows 0 degrees centigrade here. The ice is melting and melting and melting and melting, and the thermometer temperature is not changing. Always 0. That means that the ice is very pure. Nobody has put anything in that ice. Yeah, that's a very pure ice made up of water. But if the temperature is changing from 0 to, let's say, -1, or maybe the temperature is a little bit above from 0, in that case that's not a pure. Yeah. So pure material has very unique quality. For example, you are doing the density of water in this laboratory. So every time you measure the density of water, you are getting 0.998 gram per cubic centimeter. So if you get the density of, if you measure the density of water, all the time you get this number, that's the water. Yeah. If somebody has put the salt there, maybe you would get number here, not 0.998, you would get 1.5 gram per cubic centimeter. Yeah. When you measure the density of water and you get 1.5 gram per cubic centimeter, that's not water. But if you get about 1 gram per cubic centimeter, that's pure water. So pure thing has a very unique characteristics, and by looking there, that unique characteristics, we can identify whether it is pure or not. Make sense? Like it's a thumbprint. So if I have a thumbprint, nobody can represent my thumbprint, right? Just like very pure. All right. So pure substance are two kinds. One is the element, another is a compound. I already told you. So water is compound because I'm combining hydrogen with oxygen. So this is called a compound, right? And all the things that you see in the periodic table, they are called the element, and these are pure, very pure. Yeah. Good. All right, now let's look this one. We still have some time, so if you this is a data like the quantitative and qualitative, right? Quantitative and quantitative observation or properties or something like this, right? So if you are measuring something and you give the number, for example, you measure the density of water in the lab and you say, okay, my water density has 99 gram per cubic centimeter. So this 1 gram per cubic centimeter is called unit, UNIT, unit. Yeah, unit, like 1 kilogram, 2 kilogram, 1 meter, 3 meter, right? So they got unit. And this is number. This is number. So if there is number and unit sitting together, that kind of observation is called quantitative observation. Yeah, somebody is measuring something and giving some unit and number. Yeah. So that's a quantitative observation. Now, you look the water. When you are working with the water, you didn't measure the mass. There is no quantity, right? There is no unit. Now you just look at it. How does the water look like? All right. So it has no color. All right. There's no color. No color. What else? It looks like liquid. And you put hand here. It was like cold. It was cold. No number here, right? So this kind of observation are called the qualitative observation. Make sense? So if you see the number with the unit, that's a quantitative observation or quantitative measurement of materials. And if you just see the color, state, hotness or coldness, so you are looking something like this. That's a qualitative observation. So how is the board look like? The board looks like white, so that's a qualitative observation. So I take the scale and I measure from that in to that in, and maybe this is about 18 feet board. So 18 feet is quantitative observation. Make sense? So my height, how do I look like? Oh, this guy is a brown, right? So that's the qualitative observation. So how is this height? So I am 5'5". So that's the quantitative observation. Yeah. So don't think something is a only chemistry. So everywhere is the same thing. So here is the we are measuring some copper sulfate here. I put it copper sulfate here. The balance was the number. So the two that's a 0.2. I don't know. So 28.51 gram. This is showing the quantitative observation, and this one is showing the qualitative. The blue. The color is blue, and if I toss them, they look like the crystals. Yeah, they are crystalline, meaning that they can make some pressure in hand, right? It's not amorphous. Yeah, good. So that's the qualitative. The blue crystal, no smell, they are solid, so they are the qualitative, and quantitative is I have the balance is showing 20.51. That's a quantitative. Yeah. Good. So sometime when you go outside, what do you do in chemistry? Is your job is qualitative chemist or quantitative chemist? Yeah. So quantitative chemists are doing a lot of measurement and using balance, using volumetric flask, burette, pipette. So they're all quantitative measurement. Yeah. But somebody who goes to the wine industry and work there is smelling the wine. Oh, is this wine smell good? Yes, wine was very good. So he's just looking the qualitative observation. Make sense? Good. All right, so we are really moving fast. All right, so still we have time here. So this one here, if you look this one, this is one solution. So this one looks like white. And if I look at the number here, 140 milliliters. So white is the solution is white. That's a qualitative observation. 140 milliliter is there. So this is number with unit. That's a quantitative. And this is yellow. That's a qualitative. 110 milliliter. So if I look here, 110 or 120 milliliter here, that's a quantitative. So if I mix these two solutions together, I see some solid here now. That was liquid. This is also liquid. But I'm mixing this one with this one. I just take this cup and put the container, its material there, and now I start to see the solid here. Make sense? So we will be doing this kind of things in the laboratory. So I have a liquid, I have another liquid, I mix them and I get the solid. Yeah. So we call this as a precipitate. So the solid that forms by mixing two solutions together is called precipitate. So I get the solid. So what kind of solid is there? Yellow. So that's a qualitative observation. Is it solid? Yes, it is solid, qualitative. And we call that as a precipitate. I have not measured it yet. So I will filter it and dry it, and I get that solid out and put in the balance, and maybe I get 3.4 grams. Now that becomes the quantitative. Make sense? So in the laboratory, professor say, oh, it's a qualitative analysis or quantitative analysis. Qualitative, we are just looking with our eyes, touching with the hand, right? That they are all qualitative. But when we start to use the balance and volumetric flask, then we are doing the quantitative analysis. Yeah, good. These things are known things, but we just we need to understand when we start to work. Now, all right, we are almost done. All right. So, chemical and physical change. So, what is chemical change? Chemical change is completely new form, new material is formed. Yeah. So let's say I have hydrogen, I have oxygen, I have different properties. If I make the hydrogen, if I breathe hydrogen, I will die. If I breathe oxygen, I will live. Right? Now if I combine these two things, I form the water. I can't breathe with water, right? If it goes to the lung, I die, right? So this is liquid, this is gas, this is gas, this is liquid. So completely new material is formed. So this is called chemical change. Yeah. So now let's talk about the physical change. Now I have water here. So I have water here. I have water here. So this is liquid. I put in fridge. Now I put in refrigerator and I get ice here. So I look at chemical analysis here. The ice is also H2O and this water is also H2O. Did I make new thing here? Looks like new thing, but it's not a new thing. This is also H2O. This is also H2O, right? No new thing is formed. Yeah. Now, if I take out from the fridge and put out, and now I get the water again. Yeah. But I cannot simply take out the water from fridge and put in the air and I get the H2NO. That's not possible. Yeah. So this is the reversible thing. So here, no new thing is formed. Here is a H2O. Here is H2O. So same material. No new thing is formed. Can I convert H2O to liquid H2O, the ice H2O to liquid H2O? Easily. Take out from the fridge and put in the room and it convert, right? So easily I can go back. It's reversible, I can change. But this one is irreversible. Once I make the water, I cannot make hydrogen and oxygen again out of this water by simple. Make sense? Then let's look one. I have a wood here. So this is a firewood. This is a firewood. So it's a firewood. I put in the fire and I get all coals. Coal. Is that coal? Can I convert coal to firewood? Impossible, right? So this is a chemical change. Make sense? So I cannot convert coal to firewood. Impossible. So that's a chemical change. This is also chemical change. But I take water, put in the fridge, becomes ice. I take ice out and mix water. So that's still a water. Yeah. So this is the difference between physical change and chemical change. So I will talk a little bit about thermal energy in next class, and we go to the second class. Hopefully today's class was a little better. Thank you very much, everyone. Yes. ready to put in. Good. Yeah. Yeah, sure, I can see this. Yeah.
Let's see. I'm ending this one.
For our